what I think I'll talk about here is my job communicating science, because that's what I do every day. And I love what I do, but some days you can wonder, oh boy, you know, it can be difficult. And you probably, many of you have come across that with the public as well. So the title of my talk is Adventures on the Front Lines of Science Communication, and I'll start with the good news. The public absolutely loves science. I mean, they love it. Anytime I post anything on Facebook, it's neat. I will get more retweets on it, if I put it on Twitter, or more shares on Facebook for anything that's cool on science than just about anything else. And it goes across, for the most part, still academic lines, it goes across educational lines, and even, for the most part, political lines still. So here's the bad news. The public barely understands basic charts like this. I could put something like that on TV, that's okay. Although, you're pushing the envelope there. It would be better just to have the line, the straight line. Or just to have the graph without the blue line. One or the other. You get to more than 2 lines on a graph, it's not great. And they barely understand weather maps like this. I've had news directors who I've worked with for 5 or 6 years come into the weather office one day and say, Dan, I've always wondered, what's that H thing? And you notice on this map here we have a stationary front. I rarely put stationary fronts on a weather map because the public really doesn't get that. They do get warm fronts and cold fronts, a little bit. Cold fronts mainly. And most of the time, someone will call and they'll ask me a question and say, I'm wondering if it's going to rain tomorrow. And I'll say, yes, we're going to have rain tomorrow for sure. Oh, well, I didn't know there was a front coming through, but there's not a front coming through. In the public's mind, rain equal front. If I have to be very careful to say, you know, there's a front coming through, but we're not going to get any rain. Because if I say there's a front coming through tomorrow, everyone will assume rain. So some more bad news. Now, they're not going to get that at all. You know, and it's really not that bad of a chart, I mean, if you're a geek. But for TV, that would never, ever go on TV. And that includes NOVA, okay? It's just not going to make it. For most Americans, though, they only see one person connected with science each day. Think about this for a second. Yeah. Now, maybe a student would see a science teacher who has some background in science, but for most adults, they see one person each day connected with science, and that's people like me. That's my friend Paul Gross, who's the past chairman of our station science committee at the AMS. And that picture he sent me there, by the way, is something he did on TV just last week. It turns out that the radar that morning was catching the flocks of birds flying up from the shores of the lakes, Lake St. Clair around Detroit. And he stopped his weathercast and blew out most of his weathercast and showed that on TV to folks. He said, this is what we can see. This is what's going on. He did a fantastic job of it. And that's what I call passing science along to the public. But yeah, we're the only ones. So I think we have a really big responsibility to do the best we can to communicate science to the public, and the AMS gets it. We've now had the Station Science Committee going for about five and a half years now. And the AMS formed the Station Science Committee for just that reason, because the #1 connection to the public with science these days is the guy doing TV weather. Now, I have to tell you, it runs the gamut from people who still use puppets all the way up to people like my friend Jay Trobeck in Sioux Falls, South Dakota, who just finished his PhD. You have a broad range in there. So in general, we do our best as far as the AMS to get the people that really have some background in science, get them into thinking, how are you going to do a really good job of communicating? And I have to tell you right off the bat, forecasting is difficult. I love it because it's so hard. And nothing, my wife will tell you, nothing makes me happier than to hit a forecast. She has a favorite saying for when I'm really happy about a forecast. She says, you're going to break your arm patting yourself on the back. But while forecasting can be difficult, communicating it is much more difficult. The one thing meteorologists absolutely hate is to have a great forecast and the phone rings and someone says, well, you really blew that one, Dan. But you didn't. You were right on. All right, whose fault is that? Is it mine because I didn't communicate it? Is it his because he has a second-grade education and didn't watch half of it? I don't know. I would say 99% of the blame has to go to me because it's my job to communicate that forecast so that he understands it. And that can be a very difficult thing to do. Let's talk about a couple of things here. First of all, you've seen these 7-day forecast. Are we doing weather by icon now? Is that the way we communicate? Is that the better way to communicate? I mean, look at Saturday. Is it going to rain all day long? Is it going to rain for part of the day? I'm not a real fan of communicating weather by icon. I think there's a real place for it, but I think you also need, and we do, to have a text forecast for someone who wants to drill down and get a bit more information. So on our weather site at WBOC, I do a detailed text forecast every day, plus you have the icons there. Is that the right way to do it? I don't know. I'm just saying I'm struggling with that kind of thing. And now let's talk about the 40% chance of rain on Monday. The best way to explain it is the Maryland Lotto. What's your chance of winning the lotto? It's a point probability. But here's the interesting way you come up with it. And in a way, part of the area, who said a percent of the area gets it? Because that's actually involved. So here's the truth. You'll leave this today learning one piece of great weather geek stuff. If I think, say I'm forecasting for Delmarva, if I think there's an 80% chance that there's going to be rain somewhere on Delmarva tomorrow, measurable rain, and that about half of that area, half of Delmarva will get wet, but the other half won't. 80 times 50 is 40. The rain chance is 40%. That's the official way that the National Weather Service, in spite of the fact that some of their forecasters don't know this, does percentages. But that really comes out to be is a point probability. So just think of it as your chance of winning the lotto. And then, of course, you have this. The AccuWeather 45-day forecast, which was announced just last week, which prompted me to write this on my blog. Yeah, here's the good news. Most of the public knows that you can't do an accurate 45-day forecast, but they want it anyhow. Because they think it probably would be a little bit better than a guess. So the way I try to communicate this to people is to say that beyond 7 days, guess works every time. Guess beats the forecast. Before 7 days, the forecast usually wins. So beyond 7, you get a guess. And I can tell you every meteorologist in the United States who works in television has picked up the phone and had someone call and say, my daughter's getting married, and this is in the winter, on June 7th at 2 o'clock, can you tell me what the weather's going to be? Now, what do I tell that person? Do I spend some time telling them that, you know, forecasts just can't go that far? That's just crazy. No, what I tell them is the high is going to be 86 that day, the low is going to be 68, and the rain chance is 25%. And you know why I can tell them that? Because that's what the climatological average is. And that's the best forecast I can give them. And then I tell them, by the way, those are the averages. I can't give you any kind of forecast beyond 7 days. But that's your best bet. And the other thing you can do is say, by the way, the record high that day is 99, and the record low is 48. So it would have to be colder than that to break a record or hotter than that to break a record. And 95% of the time, it's within 10 degrees of these, or 8 degrees of these numbers. Then you can actually give them some good information. But mainly, they just want to know what the high is going to be and what the rain chance is going to be. They don't really want all that information. So, the 4 greatest public misconceptions about science. This is my humble opinion only. Number 1 is the public definition of theory. They don't get it. They think a theory is what I think, I believe. They think of it as a belief instead of a scientific fact. Most of the public still believe that scientists are divided about climate change. I mean, that is an overwhelming, I almost wanted to put that as number 1 because that is very high up there. People really think scientists are still divided about it. And this is one of my favorites. Most people regard anecdotal evidence as trumping scientific fact. And I'll give you a great example. When I worked in Alabama, every March, people would call me wanting to know what the date of the full moon was. And I finally asked, why do I get this every March? And someone told me, oh, they're wanting to cut the onions. What? They have to cut the onions. And I said, please explain this. He said, all right, well, if you cut the onions on the first Sunday after the full moon, the wild onions won't come back in your yard all summer long. And they wanted to know that. And this was very popular. We even had an anchor on the air who always made a big thing about giving it out to them. I said, there's nothing to this. Why don't you just say this is crazy? And of course, they were getting confirmation bias. You know, they do it once, they don't get onions that year, it works. Yeah, and they will ignore every year it didn't work and only remember the years when they didn't have wild onions. And so that people take anecdotal evidence, which science says, oh, we should investigate this. I wonder what the real truth is. The public sees anecdotal evidence and says that's scientific truth. That's something we could do. And then the number one is they really have no idea what scientific method is. They don't understand why, in my opinion, it's the greatest invention since we tamed fire. That one idea, you know, I go out and ask people, what's the greatest human invention ever? You know what I normally get? Printing press. It's up there, pretty good. Some people, you know, younger kids will say the computer. I've had a few say iPhone. But if you think about it, it's the idea that we only really believe what we can see and test. And once we, you know, as Richard Feynman said, you know, once you falsify a theory, once you have a hypothesis and you do a test and it's wrong, then it's wrong. It doesn't matter who you are, what your name is, it's wrong. And that one thing is what's taken us from living in log cabins and burning witches to going to the stars in just 250 years. That's pretty good. So, here's a question I'll throw to you. We have a lot of people who are not going to go into science, and we put them in high school, and we put them in Algebra 2, which I think they really should take. But if we don't have time to do another class on what science is, and we have to do a choice, maybe we should think about doing a whole semester in high school where people investigate scientific method and what it is. And maybe a bit of history of science thrown in place of Algebra 2. Or find some other course, you know. But I think we're graduating people who aren't going to go beyond high school or maybe just a few years at junior college, and they have no idea what science is. And I think we would have a much more educated public. You know what Carl Sagan said about it, I forget which book. So we live in a world where everything is very complicated and complex, and our daily lives are run by all of this complex machinery, yet very, very few people know how to fix it. And that is a recipe for disaster. And I was thinking about that yesterday driving over, and on the radio I turned it on, and did you know what the big news story was yesterday? What happened to the NASDAQ? The computers went down for 3 hours. All right. By the way, everything I've mentioned so far up until now is one of the things I hate about my job, and it's also why I absolutely love my job. I love doing this. And this is a picture of me standing in front of Ernest Shackleton's weather station at Cape Royds, Antarctica. The air is so dry in Antarctica, nothing falls apart. There was a dead seal down the way there that had been there for 70 years. And it hadn't you could still see it was a dead seal. It hadn't pretty much disintegrated. And some of that metal pipe there was part of the barometer, we think, that he was using. It's just been sitting there since he left. Social media is fantastic. It's turned us all into science communicators. It also can ruin your reputation and make you look really silly. I know one weather person who went on television and on social media and said that it's ridiculous to talk about the planet getting any warmer because carbon dioxide is such a small, minuscule part of the atmosphere, it couldn't possibly have an effect on temperature. I responded to him that I could put 0.01 grams of morphine in his body and he would drop dead instantly, but it didn't do any good. Here's Cape Royds, and there's Shackleton's hut. I was there right after they discovered an entire case buried in the ice of Irish whiskey. But the Antarctic Treaty says you cannot take anything off of Antarctica that was there before 1952. It's a historical site. So they had to get special permission from the nations, and they took one bottle back to test it, And the company that made it is still in business in Ireland, or in England, I forget which, and it's now on display in their company headquarters, and they said the whiskey was still drinkable. Unfortunately, they didn't show us where we couldn't get down there and get to the others, which were still down there. And that's Mount Erebus, by the way, in the background, an active volcano, so watched a lot of steam and stuff come up out of it while we were there. And this is also near a beautiful penguin colony. Walking into Shackleton's hut is an amazing experience. I mean amazing. You've probably seen it on television and documentaries, but I got to tell you, it's like walking back a century. Things still hanging around on that clothesline there. There was a newspaper, you know, in 1903, 1907, they didn't print on the lousy print they use today. That paper was still bright white and quite readable, the London Weekly News. It was amazing. And we also got to visit the dry valleys, which everyone said before I went there, we were at McMurdo, they said, it's the most beautiful place on earth, and I have to tell you, it really is. If you ever get a chance to go, I would definitely go. And I thought I'd show you, this is about a 3.5-minute video that we produced for television of what the trip to the pole was like. I was at McMurdo for about 5 days. In McMurdo, the sun is up 24 hours a day, and it's cold, but it's nothing like the pole. The pole's at 10,000 feet. The pole is like going to another planet because the air is very thin. It's, you know, a high of 0 rarely ever happens at the pole, even in the summer. And you have so much stuff. The boots you wear to keep your feet warm weigh about 5 pounds each, but they'll keep your feet warm down to -70. So you have all this equipment on, and just walking around, it really does feel like you're on the moon. But I thought I'd just show you this piece because it was one of my all-time dreams to stand at the bottom of the world since I was like 9 years old, and I had the chance to do it. And I can tell you, when I walked up to the pole, everyone was taking pictures, but I couldn't because I had tears in my eyes. I was so excited to actually be there. The 700-mile flight from McMurdo to the pole is on an LC-130 with skis instead of wheels. 3 noisy and cold hours. Shortly after 11 a.m. Monday, January 10th, I became one of only 4,000 or 5,000 human beings in all of history to have traveled to the very bottom of the world.
I can't believe it. I'm standing at the South Pole.
I had just accomplished one of my greatest life goals. We were here to see the science, and after a short lunch, we were off. Our first stop, the strangest telescope on Earth, IceCube.
Because whatever goes down here, it ain't ever coming back.
It's pointed down through the Earth toward the North Pole to detect subatomic particles called neutrinos. These particles are so small that they'll pass through almost the entire Earth without hitting anything. The few that do hit something cause a blue flash in the clear ice beneath us. Deep holes are being dug into the ice sheet and special detectors are installed. I got to sign one. And that detector with my name on it will be entombed in the ice for thousands of years. The next stop was the South Pole Telescope. It's designed to see the leftover echo of the Big Bang that started the universe.
This is a very cool feeling to have the Earth rotating around me right now.
And while the South Pole is no tourist destination, there is a place for a really good photo op. It's a moment I'll never forget.
I just joined a very exclusive club. 99 years ago next month, the very first human being set foot right here. And in all of human history, only about 4,000 people have ever stood where I'm standing. It's 13 degrees below 0. The wind chill is 30 below. It's 90 degrees south latitude. It's the South Pole. Now, it's Monday evening in New Zealand, and that's the time they go by here in Antarctica. But I'm going to walk around the world. Huntsville's that direction. It is now Sunday evening. I just crossed the international date line. It's now Monday again. That right there is the South Pole. 90 degrees south, the bottom of the world.
Since we were upside down to those of you north of the equator, Chaz Firestone of our group tried to remedy that. He failed miserably, but I got to give him an A for effort. We took snapshot after snapshot, documenting our once-in-a-lifetime trip. And then we learned our visit will be extended.
That's bad news. It means the plane can't land.
We had to spend the night at the pole.
We may be stuck here another night. And this is where we stayed, a James Way hut. It looks like it's right out of an episode of MASH. The next morning, I walked back to Amundsen Scott Station. With the extra time, we had the chance for some more weather fun. I watched the weather balloon launch from station 89007, Amundsen Scott Station, South Pole.
3, 2, and 1.
At 1 p.m., the LC-130 landed, and it was time to go. The pole is such a different, otherworldly place that it sometimes seems like a dream, but it wasn't. I was there, and my gratitude to America's National Science Foundation for the opportunity is boundless. So I told you that they don't allow anything that you bring in Antarctica, you have to bring back out. Anything brought in since 1952 has to leave. In McMurdo or at the South Pole, you actually break up your food leftovers into different trays. And it all gets shipped back, by the way, by ship once a year to Port Hueneme, California, where it's burned. So if you're ever in Port Hueneme and smell smoke in the air, that's from Antarctica. The interesting thing, though, is they had to make an exception for weather balloons, because they go way up in the stratosphere, they burst, they fall back down. So that's the only exception that can be brought into Antarctica, is a special type of weather balloon that will slowly disintegrate, but it gets buried by the snow, and that's the exception. It's a little trivia fact for you. It's the one thing they can't bring in there. But anyhow, just some pictures there real quick. If you ever get a chance, I highly recommend going there. It is an amazing, amazing place. And yes, there really is a South Pole. That's it. They change it out every year with a different piece of the science, and that year was the South Pole Telescope. And here's the crazy thing. Just 6 months later, I'm back, and I get a call from a friend of mine, Dave Jones, up in Baltimore, and he does a science communication company, works with NASA, and a good friend of his was working on the NEAM ice core drill project. And he starts asking me questions about, what it was like, and I thought, oh, you're gonna send someone up there and you need some advice. I'll be glad to talk to you. And after about 10 minutes, I realized he wanted to send me up there. And I said, yes. And so 6 months later, I'm at the top of the world, and this is some pictures from the trip. That's what NEAM looks like. It's at 7,000 feet on the Greenland ice sheet. And the only heated spot in the whole place was that big, black hand grenade. We called it the hand grenade. Otherwise, you lived in tents that were heated to 30 degrees. If you heated them above 32 degrees, the floor melted, so you kept it at 30. This picture, I think, really tells Greenland more than anything else, because I got on a little snowcat and snowmobile and drove out about 2 kilometers north of the base, stopped. It's a beautiful day. You don't do this in any but absolute perfect weather, and I let them know where I was going, because if the weather had clouded up, I would not have been able to get back. Because if I missed that hand grenade driving back, there's nothing for 800 miles till I hit the coast. But there's a station out there that sends the data to a satellite. You can actually call this up. I've got it bookmarked on the internet. And I took a picture of that just sitting in the silence. And that's the core, one of the cores. You can even see some of the ice or some of the dirt on the right. That told them after 2 kilometers they were getting to the bottom. That was the first piece of dirt. I was actually in the room when they brought up, hang on a second, when they brought up the first chunk of rock from the base. And they're just now publishing the first big science papers on NEAM, and it's fantastic. I was telling someone else earlier, you can actually run a little couple of wires that are connected to a resistor down an ice core, and where there's volcanic activity, the ice is more conductive. And they ran it down and said, you're going to hear a beep. And I went, bleep. And I said, that's the volcano that Benjamin Franklin wrote about in Iceland traveling back from Paris in the 1770s. And they know exactly what year that snow fell just by that. So here's some outtakes. This did not get on the air. And all my photography in Antarctica and in NEAM, they weren't going to send a photographer with me. It had to be me. And I'm a pretty decent still photographer, but you're going to see that my other camera skills are really not that good. So here's some outtakes. Colder than it looks.
just what it's like out here. I think we're about there, and I forgot to put my hood up. Rather chilly ride. It's about 2 degrees above zero. Need to go to the bathroom? That's just down the hall. I'll show you. See the yellow tent? That's the bathroom. Uh-oh. Oh, please open door. Pardon me while I panic. Here we go. 3, 2, 1. It's midnight. Pretty cool, eh? Due north.
Look. Hot. No! Look what? Sheet. 7, okay. Hot, cool,
Very good, guys. So Tim Burton, who's the snow manager here, he's also a survival expert. The reason he is here is to keep scientists from going out and doing something dumb and getting themselves killed. So, being the snow expert and the snow removal expert, he doesn't sleep in a tent. Tim sleeps in that, his own snow cave. He built it himself. He said, come on and take a look, just don't come while I'm sleeping. Well, can't tell what time it is by the sun here, but it's about 5:30 in the afternoon. I don't think he's sleeping. He's probably out preparing the runway. So let's go in and take a look. You gotta be careful not to hit your head coming in, but doggone it if it's not comfortable in here, and warm too. Let me set this down. Try going anywhere in, say, the southeastern United States and standing for an hour and not hearing one single sound. I bet you can't do it. You'll at least hear a jet plane fly over way up at 35,000 feet. But you can do it here. Nothing but the wind. People ask me, well, what did you see in Antarctica that I wouldn't know about? Something, and I can tell you the answer is very easy. And one of the explorers with Scott said it best. He said, we're going back to the Great White Quiet. When you land there, it is a quiet that you've never heard before. It's just amazing quiet. And that's the one thing that stays with me. That's a picture of the Russell Glacier near Iqaluit. I'm not near Iqaluit, actually. Yeah, near Iqaluit. It's about 40 miles out of Iqaluit. We went there on the way back. I got a picture of a person standing down there just to give you an idea. So I want to show you an end here with some really great examples of science communication. This is a graph that John Cook at Skeptical Science put out. He's trying to get everyone to share this graph, and it really is good. When you hear someone saying the ice is recovering, and it's not been as bad a year up in the Antarctic or the Arctic as last year, and they say, see, the Arctic ice is recovering, and he put that graph together. And he did another one on temperature, and I just did a frame of both of them together here. But this is a really good way of communicating. This is really, really, really good scientific communication. And I want to recommend a book to you. If you communicate science at all, it's a crazy title, Language Intelligence, Lessons on Persuasion from Jesus, Shakespeare, Lincoln, and Lady Gaga. That book is a must read. A lot of it I had learned the hard way. You know, and I give you an example here about telling something over and over. I would do morning weather, and I would give the temperature 14 times an hour. It would drive me crazy. It drives morning meteorologists crazy. Sunny and 74, it's 48 now. Not once did anyone ever call and say, I'm tired of you giving the temperature over and over. One, they're only watching 8 or 10 minutes of it. And two, if you want to tell someone something, you tell it to them 3 and 4 times the same way. Then you switch it around and tell it to them another 10 or 11 times. And then 10 or 12 more after that. and you've got on their radar. They probably aren't going to remember it, but you're starting to get a little bit of their attention. That's why you see the same commercials over and over and over. They're not lazy. All these commercial companies aren't lazy, saying, why don't they make a different commercial? They want you to see that same commercial 1,000 times before you'll buy their product. So I do, Joe Romm, physicist, he writes the Climate Progress blog. This was really a great book, and I highly recommend it. Now, there are a few things in my life that, I have an 18-year-old daughter at the time, she's now in her 20s, and you can't impress a teenager. I got to meet the president and the vice president of the White House, didn't impress her. I went to the South Pole, didn't impress her. I went to Greenland for 2 weeks, didn't impress her. Getting her picture taken with Dr. Neil deGrasse Tyson, priceless. In my favorite comment, and you'll see it on my blog all the time, and you might say, he said that before, and I'll keep saying it again because of what Joe Romm says in his book. You say it over and over and over. The laws of physics are real. Everything everything else is politics. And my favorite of all time science quotes from Richard Feynman, bongo player and Nobel Prize winner, science is what we do to keep from lying to ourselves. And the last thing is, it does pay to be a weatherman because Nike is coming out with weatherman shoes. Unfortunately, I grew up poor in Oklahoma, and there'll be ice skating in hell when I pay $150 for this. So thank you very much.